Okay, let's see this question. Question 9, November 2017. Okay, 9.1. Learners investigated the relationship between potential difference V and then the current I for the combination of two resistors R1 and R2. One experiment, resistors R1 and R2 were connected in parallel. In a second experiment, resistor R1 and R2 were connected in series. Now, the learners then plotted graph X and the results of one of the experiments and graph Y. The results of the other experiment are as shown below. Okay, graphs for potential difference versus current for the combination of two resistors in series and in parallel. Okay, these are the two graphs that we see here, but it's very difficult to identify which one is in series and which one is in parallel between these two. So, but now we'll see maybe on the following questions to check which one is in series and which one is in parallel. Okay. Now, I think 9.1.1, they say that state Ohm's law in words. The definition of Ohm's law in words is the difference, the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So now, this is the formula for Ohm's law. When R is constant, then V, which is potential difference, is directly proportional to I, which is the current. So this is the definition for Ohm's law. Now let's go back to the question. Now 9.1.2 is said that what physical quantity does the gradient slope of the VI graph represent? Okay, now the VI graph, this is the graph, these two graphs, which is y-axis is for potential and then the x-axis is for current. So is the voltage versus time versus current graph. Now, what is the slope here? If we have potential difference and then we have current, the relationship for current and resistance voltage, we know that is V is equals to IR. V is equals to IR. Now, is this one here? R is equals to V over I. So it means that R stands for the gradient. But now, the gradient will be equals to, actually the gradient is called equivalent resistance. Now, the equivalent resistance means that is the sum of the resistors that are connected in series or in parallel. Equivalent resistance are the sum of the resistance. So it means that there are more than one resistor. So in this situation, it means that the gradient of the slope is the resistor, but it's not one resistor, it's the equivalent of resistors. So it can be resistors in series or in parallel. So for answering this question, you can say equivalent resistance. Equivalent resistance. Okay, now 9.1.3, calculate the gradient slope of graph X. Now this is our graph X. This is our graph X. We need to calculate the gradient. So to calculate the gradient, you need to find 2 points within this graph. 2 points within this graph. Either you can say 0, 0, and 0.25, and then goes with 1.00, or here is very difficult to choose the points here. Yes, we know that is 1.50, but for current somewhere estimation, so it's very difficult to choose this one. You can choose this one here, or from 0 to 0, 0 to 0, 50, and then 2, 0, 0. So, like for instance, change in potential difference. Initial is 0, final is 2, 0. And then for change in current, initial is 0, and then final is 0, 50. Yeah, so you can take those 2 points there to calculate our gradient for x. Now let's see. Here we go. Now 9.1.3 gradient of r is equal to v2 minus v1 divided by I2 minus I1. So we take those points. We say 2 minus 0 for change in voltage. So say initial is 0, final is 2, 0. So that's why we say for potential difference, say 2, 0, 0 minus 0. And then for current, we say 0, 50, which will be minus 0 here. And then let's see,